L.O. Two simple letters marked the beginning of a new chapter in the human history. In 1969, researchers were trying to set up the first packet switch network known as ARPANET.
One has to type in LOG and the remote machine will type in the IN. What happened is Charlie typed the L, he typed the O, he typed the G. Wacko! The system crashed. So the very first message on the internet ever was low, as in lo and behold.
Hi, welcome to this next video. The very first message on the internet was hello. Today, more than 50 years later, the reality that I can reach out to you through this video is a mind-boggling fact and a constant reminder of what we have come to achieve in the past 50 years. Our world is an ever-connected place, and information is transmitted throughout the planet in real time. More than 5 billion people get connected to the internet on a daily basis. To put it into perspective, that is more than 60% of the world's population. Yeah, but what the internet is? Have patience, they are watching, you also watch. In today's video, I will answer the question of what the internet is in as simple terms as possible. So without wasting any more of your time, let us get started. Internet was not born in a day. There was a constant effort by multiple people, organizations, and governments over the course of many years that gave birth to the internet that we experience today. To answer the question of what the internet is, we have to jump back in time to the 1950s before the internet and understand some of the factors at play that eventually led to the advent of the internet. Let me present to you two such important developments. The first development was in the academic research sector with the evolution of time-sharing concept. To explain it, earlier computers were very expensive and huge in size. They had special power and infrastructure requirements and often needed a team to operate. Earlier computers were mostly installed at academic universities for research purposes. Because of these limitations, two problems emerged. First, the number of computers were proportionally less than the number of researchers. Second, the researchers who wanted to use those computers were often geographically located at some other location. The solution to these is time sharing. Time sharing is the sharing of computing resources among many users at the same time. The concept of time sharing was implemented by providing multiple small terminals spread geographically, all connected to a central mainframe. The terminals were used as remote user interfaces to provide commands to be executed on the central mainframe computer. The first implementation of time sharing for user programs was carried out at MIT in 1954, and by the late 1960s, it had turned into a commercial business. The second development was in the airline industry. To explain it further, in the 1950s, American Airlines was facing a serious problem in its ticket reservation system. The problem was, whenever someone wants to book a ticket, they would have to call up the agent who would then manually sort through the list of flights, mark the seat as reserved, and print the ticket. The entire end-to-end task of looking for a flight, reserving a seat, and then writing the ticket takes approximately 1.5 hours on average. During a time when the airline industry was witnessing a boom, these manual reservation systems were not at all scalable as they were time-consuming, unreliable, and error-prone. IBM collaborated with American Airlines to build the world's first online ticket reservation system. which went live in the 1960s with two mainframe computers connected over a network. By the late 1970s, almost all major airlines had similar online reservation systems. All throughout the 20th century, while the computers were going through a technological revolution, there had been significant advancements in telecommunication technologies as well. By the late 1950s, it was possible to make cross-continental telephone calls, and the dawn of undersea submarine cables began with the inauguration of TAT-1 cable. All such synergies combined together, and the world was becoming more and more connected with the launch of Advanced Research Projects Agency Network, or ARPANET for short. The motivation to create ARPANET can be summarized in the words of Charles Hertzfeld, and I quote, "The ARPANET came out of our frustration that there were only a limited number of large, powerful research computers in the country, and that many research investigators who should have access to them were geographically separated from them." End quote. ARPANET was not like a one big network, but instead multiple small academic networks were interconnected to the main backbone using small microcomputers known as Interface Message Processors, or IMPs. Today, IMPs are better known as routers. There is a huge significance to the launch of ARPANET. The ARPANET was the first wide area packet switched network. In a packet switch network, first messages are divided into small packets, then transmitted over the network, and finally individual packets are assembled into the single message at the receiver's end. This is radically different from traditional voice and data communication networks, which worked on the principles of circuit switching, wherein a fully dedicated end-to-end electronic channel is established between two communicating stations, thereby completing a circuit. The main challenge with such networks is that since each terminal needs to establish a circuit, they have to pre-allocate bandwidth for each connected node. The pre-allocated bandwidth is wasted if the node is not transmitting data. This problem was fixed by packet switch networks, where such unused bandwidth is used by other nodes who are transmitting the data at that given instant. Transmission Control Protocol and Internet Protocol are the two foundational stones for packet switch networks. The United States government standardized the TCP/IP protocol in 1982, thus fueling the growth of multiple small packet switching networks all across the planet. We will learn more about TCP/IP protocols in the next video. In the mid-1980s, access to the packet switch networks was expanded with the launch of National Science Foundation Network, which provided access to supercomputing sites in the United States for researchers. By the late 1980s, National Science Foundation Network had expanded to academic and research organizations all across Europe, Australia, New Zealand, and Japan. All of these smaller networks are connected together using multiple routers and cables at physical internet exchange points spread all across the globe. So ultimately, what we get is a network of networks, which is why we call it the Internet. Internet is a shorthand for internet working. Internet working is the practice of interconnecting multiple computer networks such that any host can communicate with any other host in the network, irrespective of their hardware level networking technologies. This is what the Internet is. Internet is a global system of interconnected computer networks. By the end of 1995, the Internet was fully commercialized in the United States. There is a general myth that cross-continental communication within the Internet is provided by satellites. However, it is not the case, as wireless networks can never handle the bandwidth required for cross-continental data transfer. Such cross-continental communication is made possible by the undersea fiber optic cables network that we have built in the past 50 years. To efficiently communicate with each other, it is very important to identify each computer uniquely on the network. Like physical addresses of the building, computers on the network must have an address associated with them. Each computer on the network has a logical address associated with it known as Internet Protocol or IP address. IP address is a combination of 4 numbers separated by a dot. Each number has a minimum value of 0 and a maximum value of 255. Traffic is forwarded from one node to another node in the network with the help of routers and relays installed all throughout the network. We can use a simple traceroute command to trace possible routes. The signals from my laptop are first transmitted to my home router. From there, it is propagated to the local backbone, then to the regional backbone, then through undersea cables back to the regional networks on the other side of the planet. Now do pay attention. The most important takeaway from this is during the early years of the internet, there was no generalized way to share information among many computers. Gopher was a very popular text-based protocol during the early years of the internet. To access Gopher sites, we would have to use links, a text-based browser, and information is organized in a file-like hierarchical arrangement on the server. We use left or right arrow keys to jump back or forward in the directory structure. As you can imagine, this is nowhere close to how we access the internet today. The technological advancements that we see today are all thanks to one visionary man, Tim Berners-Lee. Tim Berners-Lee is credited with the invention of World Wide Web. World Wide Web, or web as we call it, is an information system enabling documents and other web resources to be accessed over the internet. He created a standard mechanism, basically an abstraction on top of the TCP/IP protocol suite, which allows for a generalized way of accessing information. Hypertext Transfer Protocol, or HTTP, is the foundation of data communication for the World Wide Web, where information is transferred in the form of hypertext documents. With that, we have come to the end of this video. In the next video, we will learn the basics of web from a technical standpoint. One request before I wrap up this video: if you are liking the content on this channel, click on that subscribe button. It really helps the channel grow. As always, thank you and keep learning. I will see you in the next one. Bye.